Chapter 12. Geographical Distribution, Continued. Distribution of Freshwater Productions. On the inhabitants of oceanic islands. Absence of batrachians and of terrestrial mammals. On the relation of the inhabitants of islands to those of the nearest mainland. On colonization from the nearest source with subsequent modification. Summary of the last and present chapters. As lakes and river systems are separated from each other by barriers of land, it might have been thought that freshwater productions would not have ranged widely within the same country, and as the sea is apparently a still more impassable barrier, that they never would have extended to distant countries. But the case is exactly the reverse. Not only have many freshwater species, belonging to quite different classes, an enormous range, but allied species prevail in a remarkable manner throughout the world. I well remember, when first collecting in the fresh waters of Brazil, feeling much surprise at the similarity of the freshwater insects, shells, etc., and at the dissimilarity of the surrounding terrestrial beings, compared with those of Britain. But this power in freshwater productions of ranging widely, though so unexpected, can, I think, in most cases be explained by their having become fitted, in a manner highly useful to them, for short and frequent migrations from pond to pond, or from stream to stream, and liability to wide dispersal would follow from this capacity as an almost necessary consequence. We can here consider only a few cases. In regard to fish, I believe that the same species never occur in the fresh waters of distant continents. But on the same continent the species often range widely and almost capriciously, for two river systems will have some fish in common and some different. A few facts seem to favor the possibility of their occasional transport by accidental means, like that of the live fish not rarely dropped by whirlwinds in India, and the vitality of their ova when removed from the water. But I am inclined to attribute the dispersal of freshwater fish mainly to slight changes within the recent period in the level of the land, having caused rivers to flow into each other. Instances, also, could be given of this having occurred during floods, without any change of level. We have evidence in the loess of the Rhine of considerable changes of level in the land within a very recent geological period, and when the surface was peopled by existing land and freshwater shells. The wide difference of the fish on opposite sides of continuous mountain ranges, which from an early period must have parted river systems and completely prevented their inosculation, seems to lead to this same conclusion. With respect to allied freshwater fish occurring at very distant points of the world, no doubt there are many cases which cannot at present be explained, but some freshwater fish belong to very ancient forms, and in such cases there will have been ample time for great geographical changes, and consequently time and means for much migration. In the second place, saltwater fish can with care be slowly accustomed to live in fresh water, and, according to Valenciennes, there is hardly a single group of fishes confined exclusively to fresh water, so that we may imagine that a marine member of a freshwater group might travel far along the shores of the sea, and subsequently become modified and adapted to the fresh waters of a distant land. Some species of freshwater shells have a very wide range, and allied species, which, on my theory, are descended from a common parent and must have proceeded from a single source, prevail throughout the world. Their distribution at first perplexed me much, as their ova are not likely to be transported by birds, and they are immediately killed by sea water, as are the adults. I could not even understand how some naturalized species have rapidly spread throughout the same country. But two facts, which I have observed, and no doubt many others remain to be observed, throw some light on this subject. When a duck suddenly emerges from a pond covered with duckweed, I have twice seen these little plants adhering to its back, and it has happened to me, in removing a little duckweed from one aquarium to another, that I have quite unintentionally stocked the one with freshwater shells from the other. But another agency is perhaps more effectual. I suspended a duck's feet, which might represent those of a bird sleeping in a natural pond, in an aquarium, where many ova of freshwater shells were hatching, and I found that numbers of the extremely minute and just hatched shells crawled on the feet, and clung to them so firmly that when taken out of the water they could not be jarred off, though at a somewhat more advanced age they would voluntarily drop off. These just hatched mollusks, though aquatic in their nature, survived on the duck's feet, in damp air, from 12 to 20 hours, and in this length of time a duck or heron might fly at least 600 or 700 miles, and would be sure to alight on a pool or rivulet, if blown across sea to an oceanic island or to any other distant point. Sir Charles Lyell also informs me that a Didicus has been caught with an Ensilus, a freshwater shell like a limpet, firmly adhering to it, and a water beetle of the same family, a columbetes, once flew on board the Beagle, when 45 miles distant from the nearest land. How much farther it might have flown with a favoring gale no one can tell. With respect to plants, it has long been known what enormous ranges many freshwater and even marsh species have, both over continents and to the most remote oceanic islands. This is strikingly shown, as remarked by Alf. de Condal, in large groups of terrestrial plants, which have only a very few aquatic members, for these latter seem immediately to acquire, as if in consequence, a very wide range. I think favorable means of dispersal explain this fact. I have before mentioned that earth occasionally, though rarely, adheres in some quantity to the feet and beaks of birds. Wading birds, which frequent the muddy edges of ponds, if suddenly flushed, would be the most likely to have muddy feet. Birds of this order I can show are the greatest wanderers, and are occasionally found on the most remote and barren islands in the open ocean. They would not be likely to alight on the surface of the sea, so that the dirt would not be washed off their feet. When making land, they would be sure to fly to their natural freshwater haunts. I do not believe that botanists are aware how charged the mud of ponds is with seeds. I have tried several little experiments, but will here give only the most striking case. I took in February 3 tablespoonfuls of mud from 3 different points, beneath water, on the edge of a little pond. This mud when dry weighed only 6 3/4 ounces. I kept it covered up in my study for 6 months, pulling up and counting each plant as it grew. The plants were of many kinds, and were altogether 537 in number, and yet the viscid mud was all contained in a breakfast cup. Considering these facts, I think it would be an inexplicable circumstance if water birds did not transport the seeds of freshwater plants to vast distances, and if consequently the range of these plants was not very great. The same agency may have come into play with the eggs of some of the smaller freshwater animals. Other and unknown agencies probably have also played a part. I have stated that freshwater fish eat some kinds of seeds, though they reject many other kinds after having swallowed them. Even small fish swallow seeds of moderate size, as of the yellow water lily and Potamogeton. Herons and other birds, century after century, have gone on daily devouring fish. They then take flight and go to other waters, or are blown across the sea, and we have seen that seeds retain their power of germination, when rejected in pellets or in excrement, many hours afterwards. When I saw the great size of the seeds of that fine water lily, the Nelumbium, and remembered Alf. de Condal's remarks on this plant, I thought that its distribution must remain quite inexplicable, but Audubon states that he found the seeds of the great southern water lily, probably, according to Dr. Hooker, the Nelumbium luteum, in a heron's stomach. Although I do not know the fact, yet analogy makes me believe that a heron flying to another pond and getting a hearty meal of fish, would probably reject from its stomach a pellet containing the seeds of the Nelumbium undigested, or the seeds might be dropped by the bird whilst feeding its young, in the same way as fish are known sometimes to be dropped. In considering these several means of distribution, it should be remembered that when a pond or stream is first formed, for instance, on a rising islet, it will be unoccupied, and a single seed or egg will have a good chance of succeeding. Although there will always be a struggle for life between the individuals of the species, however few, already occupying any pond, yet as the number of kinds is small, compared with those on the land, the competition will probably be less severe between aquatic than between terrestrial species. Consequently, an intruder from the waters of a foreign country would have a better chance of seizing on a place than in the case of terrestrial colonists. We should, also, remember that some, perhaps many, fresh water productions are low in the scale of nature, and that we have reason to believe that such low beings change or become modified less quickly than the high, and this will give longer time than the average for the migration of the same aquatic species. We should not forget the probability of many species having formerly ranged as continuously as freshwater productions ever can range, over immense areas, and having subsequently become extinct in intermediate regions. But the wide distribution of freshwater plants and of the lower animals, whether retaining the same identical form or in some degree modified, I believe mainly depends on the wide dispersal of their seeds and eggs by animals, more especially by freshwater birds, which have large powers of flight, and naturally travel from one to another and often distant piece of water. Nature, like a careful gardener, thus takes her seeds from a bed of a particular nature, and drops them in another equally well fitted for them. On the inhabitants of oceanic islands. We now come to the last of the three classes of facts, which I have selected as presenting the greatest amount of difficulty, on the view that all the individuals both of the same and of allied species have descended from a single parent, and therefore have all proceeded from a common birthplace, notwithstanding that in the course of time they have come to inhabit distant points of the globe. I have already stated that I cannot honestly admit Forbes's view on continental extensions, which, if legitimately followed out, would lead to the belief that within the recent period all existing islands have been nearly or quite joined to some continent. This view would remove many difficulties, but it would not, I think, explain all the facts in regard to insular productions. In the following remarks I shall not confine myself to the mere question of dispersal, but shall consider some other facts, which bear on the truth of the two theories of independent creation and of descent with modification. The species of all kinds which inhabit oceanic islands are few in number compared with those on equal continental areas. Ulf. De Condal admits this for plants, and Wollaston for insects. If we look to the large size and varied stations of New Zealand, extending over 780 miles of latitude, and compare its flowering plants, only 750 in number, with those on an equal area at the Cape of Good Hope or in Australia, we must, I think, admit that something quite independently of any difference in physical conditions has caused so great a difference in number. Even the uniform county of Cambridge has 847 plants, and the little island of Anglesey 764, but a few ferns and a few introduced plants are included in these numbers, and the comparison in some other respects is not quite fair. We have evidence that the barren island of Ascension aboriginally possessed under half a dozen flowering plants, yet many have become naturalized on it, as they have on New Zealand and on every other oceanic island which can be named. In St. Helena there is reason to believe that the naturalized plants and animals have nearly or quite exterminated many native productions. He who admits the doctrine of the creation of each separate species, will have to admit that a sufficient number of the best adapted plants and animals have not been created on oceanic islands, for man has unintentionally stocked them from various sources far more fully and perfectly than has nature. Although in oceanic islands the number of kinds of inhabitants is scanty, the proportion of endemic species, i.e. those found nowhere else in the world, is often extremely large. If we compare, for instance, the number of the endemic land shells in Madeira, or of the endemic birds in the Galapagos archipelago, with the number found on any continent, and then compare the area of the islands with that of the continent, we shall see that this is true. This fact might have been expected on my theory. For, as already explained, species occasionally arriving after long intervals in a new and isolated district, and having to compete with new associates, will be eminently liable to modification, and will often produce groups of modified descendants. But it by no means follows that, because in an island nearly all the species of one class are peculiar, those of another class, or of another section of the same class, are peculiar, and this difference seems to depend on the species which do not become modified having immigrated with facility and in a body, so that their mutual relations have not been much disturbed. Thus in the Galapagos Islands nearly every land bird, but only 2 out of the 11 marine birds, are peculiar, and it is obvious that marine birds could arrive at these islands more easily than land birds. Bermuda, on the other hand, which lies at about the same distance from North America as the Galapagos Islands do from South America, and which has a very peculiar soil, does not possess one endemic land bird, and we know from Mr. J. M. Jones's admirable account of Bermuda, that very many North American birds, during their great annual migrations, visit either periodically or occasionally this island. Madeira does not possess one peculiar bird, and many European and African birds are almost every year blown there, as I am informed by Mr. E. V. Harcourt. So that these two islands of Bermuda and Madeira have been stocked by birds, which for long ages have struggled together in their former homes, and have become mutually adapted to each other, and when settled in their new homes, each kind will have been kept by the others to their proper places and habits, and will consequently have been little liable to modification. Madeira, again, is inhabited by a wonderful number of peculiar land shells, whereas not one species of seashell is confined to its shores. Now, though we do not know how seashells are dispersed, yet we can see that their eggs or larvae, perhaps attached to seaweed or floating timber, or to the feet of wading birds, might be transported far more easily than land shells, across 300 or 400 miles of open sea. The different orders of insects in Madeira apparently present analogous facts. Oceanic islands are sometimes deficient in certain classes, and their places are apparently occupied by the other inhabitants. In the Galapagos Islands reptiles, and in New Zealand gigantic wingless birds, take the place of mammals. In the plants of the Galapagos Islands, Dr. Hooker has shown that the proportional numbers of the different orders are very different from what they are elsewhere. Such cases are generally accounted for by the physical conditions of the islands, but this explanation seems to me not a little doubtful. Facility of immigration, I believe, has been at least as important as the nature of the conditions. Many remarkable little facts could be given with respect to the inhabitants of remote islands. For instance, in certain islands not tenanted by mammals, some of the endemic plants have beautifully hooked seeds, yet few relations are more striking than the adaptation of hooked seeds for transportal by the wool and fur of quadrupeds. This case presents no difficulty on my view, for a hooked seed might be transported to an island by some other means, and the plant then becoming slightly modified, but still retaining its hooked seeds, would form an endemic species, having as useless an appendage as any rudimentary organ, for instance, as the shriveled wings under the soldered elytra of many insular beetles. Again, islands often possess trees or bushes belonging to orders which elsewhere include only herbaceous species, now trees, as Alf. De Condal has shown, generally have, whatever the cause may be, confined ranges. Hence trees would be little likely to reach distant oceanic islands, and an herbaceous plant, though it would have no chance of successfully competing in stature with a fully developed tree, when established on an island and having to compete with herbaceous plants alone, might readily gain an advantage by growing taller and overtopping the other plants. If so, natural selection would often tend to add to the stature of herbaceous plants when growing on an island, to whatever order they belonged, and thus convert them first into bushes and ultimately into trees. With respect to the absence of whole orders on oceanic islands, Bory St. Vincent long ago remarked that batrachians, frogs, toads, newts, have never been found on any of the many islands with which the great oceans are studded. I have taken pains to verify this assertion, and I have found it strictly true. I have, however, been assured that a frog exists on the mountains of the great island of New Zealand, but I suspect that this exception, if the information be correct, may be explained through glacial agency. This general absence of frogs, toads, and newts on so many oceanic islands cannot be accounted for by their physical conditions. Indeed, it seems that islands are peculiarly well fitted for these animals, for frogs have been introduced into Madeira, the Azores, and Mauritius, and have multiplied so as to become a nuisance. But as these animals and their spawn are known to be immediately killed by sea water, on my view we can see that there would be great difficulty in their transportal across the sea, and therefore why they do not exist on any oceanic island. But why, on the theory of creation, they should not have been created there, it would be very difficult to explain. Mammals offer another and similar case. I have carefully searched the oldest voyages, but have not finished my search. As yet I have not found a single instance, free from doubt, of a terrestrial mammal, excluding domesticated animals kept by the natives, inhabiting an island situated above 300 miles from a continent or great continental island, and many islands situated at a much less distance are equally barren. The Falkland Islands, which are inhabited by a wolf-like fox, come nearest to an exception, but this group cannot be considered as oceanic, as it lies on a bank connected with the mainland. Moreover, icebergs formerly brought boulders to its western shores, and they may have formerly transported foxes, as so frequently now happens in the Arctic regions. Yet it cannot be said that small islands will not support small mammals, for they occur in many parts of the world on very small islands, if close to a continent, and hardly an island can be named on which our smaller quadrupeds have not become naturalized and greatly multiplied. It cannot be said, on the ordinary view of creation, that there has not been time for the creation of mammals. Many volcanic islands are sufficiently ancient, as shown by the stupendous degradation which they have suffered and by their tertiary strata. There has also been time for the production of endemic species belonging to other classes, and on continents it is thought that mammals appear and disappear at a quicker rate than other and lower animals. Though terrestrial mammals do not occur on oceanic islands, aerial mammals do occur on almost every island. New Zealand possesses 2 bats found nowhere else in the world: Norfolk Island, the Viti Archipelago, the Bonin Islands, the Caroline and Marianne Archipelagos, and Mauritius, all possess their peculiar bats. Why, it may be asked, has the supposed creative force produced bats and no other mammals on remote islands? On my view, this question can easily be answered, for no terrestrial mammal can be transported across a wide space of sea, but bats can fly across. Bats have been seen wandering by day far over the Atlantic Ocean, and 2 North American species either regularly or occasionally visit Bermuda, at the distance of 600 miles from the mainland. I hear from Mr. Tomes, who has specially studied this family, that many of the same species have enormous ranges, and are found on continents and on far distant islands. Hence we have only to suppose that such wandering species have been modified through natural selection in their new homes in relation to their new position, and we can understand the presence of endemic bats on islands, with the absence of all terrestrial mammals. Besides the absence of terrestrial mammals in relation to the remoteness of islands from continents, there is also a relation, to a certain extent independent of distance, between the depth of the sea separating an island from the neighboring mainland, and the presence in both of the same mammiferous species or of allied species in a more or less modified condition. Mr. Windsor Earle has made some striking observations on this head in regard to the Great Malay Archipelago, which is traversed near Celebes by a space of deep ocean, and this space separates 2 widely distinct mammalian faunas. On either side the islands are situated on moderately deep submarine banks, and they are inhabited by closely allied or identical quadrupeds. No doubt some few anomalies occur in this great archipelago, and there is much difficulty in forming a judgment in some cases owing to the probable naturalization of certain mammals through man's agency, but we shall soon have much light thrown on the natural history of this archipelago by the admirable zeal and researches of Mr. Wallace. I have not as yet had time to follow up this subject in all other quarters of the world, but as far as I have gone, the relation generally holds good. We see Britain separated by a shallow channel from Europe, and the mammals are the same on both sides. We meet with analogous facts on many islands separated by similar channels from Australia. The West Indian Islands stand on a deeply submerged bank, nearly 1,000 fathoms in depth, and here we find American forms, but the species and even the genera are distinct. As the amount of modification in all cases depends to a certain degree on the lapse of time, and as during changes of level it is obvious that islands separated by shallow channels are more likely to have been continuously united within a recent period to the mainland than islands separated by deeper channels, we can understand the frequent relation between the depth of the sea and the degree of affinity of the mammalian inhabitants of islands with those of a neighboring continent, an inexplicable relation on the view of independent acts of creation. All the foregoing remarks on the inhabitants of oceanic islands, namely, the scarcity of kinds, the richness in endemic forms in particular classes or sections of classes, the absence of whole groups, as of batrachians, and of terrestrial mammals notwithstanding the presence of aerial bats, the singular proportions of certain orders of plants, herbaceous forms having been developed into trees, etc., seem to me to accord better with the view of occasional means of transport having been largely efficient in the long course of time, than with the view of all our oceanic islands having been formerly connected by continuous land with the nearest continent, for on this latter view the migration would probably have been more complete, and if modification be admitted, all the forms of life would have been more equally modified, in accordance with the paramount importance of the relation of organism to organism. I do not deny that there are many and grave difficulties in understanding how several of the inhabitants of the more remote islands, whether still retaining the same specific form or modified since their arrival, could have reached their present homes. But the probability of many islands having existed as halting places, of which not a wreck now remains, must not be overlooked. I will here give a single instance of one of the cases of difficulty. Almost all oceanic islands, even the most isolated and smallest, are inhabited by land shells, generally by endemic species, but sometimes by species found elsewhere. Dr. August A. Gould has given several interesting cases in regard to the land shells of the islands of the Pacific. Now it is notorious that land shells are very easily killed by salt. Their eggs, at least such as I have tried, sink in seawater and are killed by it. Yet there must be, on my view, some unknown, but highly efficient means for their transportal. Would the just hatched young occasionally crawl on and adhere to the feet of birds roosting on the ground, and thus get transported? It occurred to me that land shells, when hibernating and having a membranous diaphragm over the mouth of the shell, might be floated in chinks of drifted timber across moderately wide arms of the sea. And I found that several species did in this state withstand uninjured an immersion in seawater during 7 days. One of these shells was the Helix pomatia, and after it had again hibernated I put it in seawater for 20 days, and it perfectly recovered. As this species has a thick calcareous operculum, I removed it, and when it had formed a new membranous one, I immersed it for 14 days in seawater, and it recovered and crawled away, but more experiments are wanted on this head. The most striking and important fact for us in regard to the inhabitants of islands, is their affinity to those of the nearest mainland, without being actually the same species. Numerous instances could be given of this fact. I will give only one, that of the Galapagos archipelago, situated under the equator, between 500 and 600 miles from the shores of South America. Here almost every product of the land and water bears the unmistakable stamp of the American continent. There are 26 land birds, and 25 of these are ranked by Mr. Gould as distinct species, supposed to have been created here, yet the close affinity of most of these birds to American species in every character, in their habits, gestures, and tones of voice, was manifest. So it is with the other animals, and with nearly all the plants, as shown by Dr. Hooker in his admirable memoir on the flora of this archipelago. The naturalist, looking at the inhabitants of these volcanic islands in the Pacific, distant several hundred miles from the continent, yet feels that he is standing on American land. Why should this be so? Why should the species which are supposed to have been created in the Galapagos archipelago, and nowhere else, bear so plain a stamp of affinity to those created in America? There is nothing in the conditions of life, in the geological nature of the islands, in their height or climate, or in the proportions in which the several classes are associated together, which resembles closely the conditions of the South American coast. In fact, there is a considerable dissimilarity in all these respects. On the other hand, there is a considerable degree of resemblance in the volcanic nature of the soil, in climate, height, and size of the islands, between the Galapagos and Cape de Verde archipelagos, but what an entire and absolute difference in their inhabitants. The inhabitants of the Cape de Verde Islands are related to those of Africa, like those of the Galapagos to America. I believe this grand fact can receive no sort of explanation on the ordinary view of independent creation, whereas on the view here maintained, it is obvious that the Galapagos Islands would be likely to receive colonists, whether by occasional means of transport or by formerly continuous land, from America, and the Cape de Verde Islands from Africa, and that such colonists would be liable to modification, the principle of inheritance still betraying their original birthplace. Many analogous facts could be given, Indeed, it is an almost universal rule that the endemic productions of islands are related to those of the nearest continent, or of other near islands. The exceptions are few, and most of them can be explained. Thus the plants of Kerguelen Land, though standing nearer to Africa than to America, are related. And that very closely, as we know from Dr. Hooker's account, to those of America, but on the view that this island has been mainly stocked by seeds brought with earth and stones on icebergs, drifted by the prevailing currents, this anomaly disappears. New Zealand in its endemic plants is much more closely related to Australia, the nearest mainland, than to any other region, and this is what might have been expected, but it is also plainly related to South America, which, although the next nearest continent, is so enormously remote, that the fact becomes an anomaly. But this difficulty almost disappears on the view that both New Zealand, South America, and other southern lands were long ago partially stocked from a nearly intermediate though distant point, namely from the Antarctic islands, when they were clothed with vegetation, before the commencement of the glacial period. The affinity, which, though feeble, I am assured by Dr. Hooker is real, between the flora of the southwestern corner of Australia and of the Cape of Good Hope, is a far more remarkable case, and is at present inexplicable, but this affinity is confined to the plants, and will, I do not doubt, be some day explained. The law which causes the inhabitants of an archipelago, though specifically distinct, to be closely allied to those of the nearest continent, we sometimes see displayed on a small scale, yet in a most interesting manner, within the limits of the same archipelago. Thus the several islands of the Galapagos archipelago are tenanted, as I have elsewhere shown, in a quite marvelous manner, by very closely related species, so that the inhabitants of each separate island, though mostly distinct, are related in an incomparably closer degree to each other than to the inhabitants of any other part of the world. And this is just what might have been expected on my view, for the islands are situated so near each other that they would almost certainly receive immigrants from the same original source, or from each other. But this dissimilarity between the endemic inhabitants of the islands may be used as an argument against my views, for it may be asked, how has it happened in the several islands situated within sight of each other, having the same geological nature, the same height, climate, etc., that many of the immigrants should have been differently modified, though only in a small degree? This long appeared to me a great difficulty, but it arises in chief part from the deeply seated error of considering the physical conditions of a country as the most important for its inhabitants, whereas it cannot, I think, be disputed that the nature of the other inhabitants, with which each has to compete, is at least as important, and generally a far more important element of success. Now if we look to those inhabitants of the Galapagos archipelago which are found in other parts of the world, laying on one side for the moment the endemic species, which cannot be here fairly included, as we are considering how they have come to be modified since their arrival, we find a considerable amount of difference in the several islands. This difference might indeed have been expected on the view of the islands having been stocked by occasional means of transport, a seed, for instance, of one plant having been brought to one island, and that of another plant to another island. Hence when in former times an immigrant settled on any one or more of the islands, or when it subsequently spread from one island to another, it would undoubtedly be exposed to different conditions of life in the different islands, for it would have to compete with different sets of organisms. A plant, for instance, would find the best fitted ground more perfectly occupied by distinct plants in one island than in another, and it would be exposed to the attacks of somewhat different enemies. If then it varied, natural selection would probably favor different varieties in the different islands. Some species, however, might spread and yet retain the same character throughout the group, just as we see on continents some species spreading widely and remaining the same. The really surprising fact in this case of the Galapagos archipelago, and in a lesser degree in some analogous instances, is that the new species formed in the separate islands have not quickly spread to the other islands. But the islands, though in sight of each other, are separated by deep arms of the sea, in most cases wider than the British Channel, and there is no reason to suppose that they have at any former period been continuously united. The currents of the sea are rapid and sweep across the archipelago, and gales of wind are extraordinarily rare, so that the islands are far more effectually separated from each other than they appear to be on a map. Nevertheless, a good many species, both those found in other parts of the world and those confined to the archipelago, are common to the several islands, and we may infer from certain facts that these have probably spread from some one island to the others. But we often take, I think, an erroneous view of the probability of closely allied species invading each other's territory, when put into free intercommunication. Undoubtedly, if one species has any advantage whatever over another, it will in a very brief time wholly or in part supplant it, but if both are equally well fitted for their own places in nature, both probably will hold their own places and keep separate for almost any length of time. Being familiar with the fact that many species, naturalized through man's agency, have spread with astonishing rapidity over new countries, we are apt to infer that most species would thus spread. But we should remember that the forms which become naturalized in new countries are not generally closely allied to the aboriginal inhabitants, but are very distinct species, belonging in a large proportion of cases, as shown by Alf. de Candolle, to distinct genera. In the Galapagos archipelago, many even of the birds, though so well adapted for flying from island to island, are distinct on each. Thus there are 3 closely allied species of mocking thrush, each confined to its own island. Now let us suppose the mocking thrush of Chatham Island to be blown to Charles Island, which has its own mocking thrush. Why should it succeed in establishing itself there? We may safely infer that Charles Island is well stocked with its own species, for annually more eggs are laid there than can possibly be reared, and we may infer that the mocking thrush peculiar to Charles Island is at least as well fitted for its home as is the species peculiar to Chatham Island. Sir C. Lyell and Mr. Wollaston have communicated to me a remarkable fact bearing on this subject, namely, that Madeira and the adjoining islet of Porto Santo possess many distinct but representative land shells, some of which live in crevices of stone, and although large quantities of stone are annually transported from Porto Santo to Madeira, yet this latter island has not become colonized by the Porto Santo species. Nevertheless, both islands have been colonized by some European land shells, which no doubt had some advantage over the indigenous species. From these considerations, I think we need not greatly marvel at the endemic and representative species, which inhabit the several islands of the Galapagos archipelago, not having universally spread from island to island. In many other instances, as in the several districts of the same continent, preoccupation has probably played an important part in checking the commingling of species under the same conditions of life. Thus, the southeast and southwest corners of Australia have nearly the same physical conditions, and are united by continuous land, yet they are inhabited by a vast number of distinct mammals, birds, and plants. The principle which determines the general character of the fauna and flora of oceanic islands, namely, that the inhabitants, when not identically the same, yet are plainly related to the inhabitants of that region whence colonists could most readily have been derived, the colonists having been subsequently modified and better fitted to their new homes, is of the widest application throughout nature. We see this on every mountain, in every lake and marsh. For alpine species, excepting in so far as the same forms, chiefly of plants, have spread widely throughout the world during the recent glacial epoch, are related to those of the surrounding lowlands. Thus we have in South America, alpine hummingbirds, alpine rodents, alpine plants, etc., all of strictly American forms, and it is obvious that a mountain, as it became slowly upheaved, would naturally be colonized from the surrounding lowlands. So it is with the inhabitants of lakes and marshes, excepting in so far as great facility of transport has given the same general forms to the whole world. We see this same principle in the blind animals inhabiting the caves of America and of Europe. Other analogous facts could be given. And it will, I believe, be universally found to be true, that wherever in 2 regions, let them be ever so distant, many closely allied or representative species occur, there will likewise be found some identical species, showing, in accordance with the foregoing view, that at some former period there has been intercommunication or migration between the 2 regions. And wherever many closely allied species occur, there will be found many forms which some naturalists rank as distinct species, and some as varieties, these doubtful forms showing us the steps in the process of modification. This relation between the power and extent of migration of a species, either at the present time or at some former period under different physical conditions, and the existence at remote points of the world of other species allied to it, is shown in another and more general way. Mr. Gould remarked to me long ago, that in those genera of birds which range over the world, many of the species have very wide ranges. I can hardly doubt that this rule is generally true, though it would be difficult to prove it. Amongst mammals, we see it strikingly displayed in bats, and in a lesser degree in the Felidae and Canidae. We see it, if we compare the distribution of butterflies and beetles. So it is with most freshwater productions, in which so many genera range over the world, and many individual species have enormous ranges. It is not meant that in world-ranging genera all the species have a wide range, or even that they have on an average a wide range, but only that some of the species range very widely, for the facility with which widely ranging species vary and give rise to new forms will largely determine their average range. For instance, two varieties of the same species inhabit America and Europe, and the species thus has an immense range, but, if the variation had been a little greater, the two varieties would have been ranked as distinct species, and the common range would have been greatly reduced. Still less is it meant that a species which apparently has the capacity of crossing barriers and ranging widely, as in the case of certain powerfully winged birds, will necessarily range widely, for we should never forget that to range widely implies not only the power of crossing barriers, but the more important power of being victorious in distant lands in the struggle for life with foreign associates. But on the view of all the species of a genus having descended from a single parent, though now distributed to the most remote points of the world, we ought to find, and I believe as a general rule we do find, that some at least of the species range very widely, for it is necessary that the unmodified parent should range widely, undergoing modification during its diffusion, and should place itself under diverse conditions favorable for the conversion of its offspring, firstly into new varieties and ultimately into new species. In considering the wide distribution of certain genera, we should bear in mind that some are extremely ancient, and must have branched off from a common parent at a remote epoch, so that in such cases there will have been ample time for great climatal and geographical changes and for accidents of transport, and consequently for the migration of some of the species into all quarters of the world, where they may have become slightly modified in relation to their new conditions. There is, also, some reason to believe from geological evidence that organisms low in the scale within each great class generally change at a slower rate than the higher forms, and consequently the lower forms will have had a better chance of ranging widely and of still retaining the same specific character. This fact, together with the seeds and eggs of many low forms being very minute and better fitted for distant transportation, probably accounts for a law which has long been observed, and which has lately been admirably discussed by Alf. de Candolle in regard to plants, namely, that the lower any group of organisms is, the more widely it is apt to range. The relations just discussed, namely, low and slowly changing organisms ranging more widely than the high, some of the species of widely ranging genera themselves ranging widely, such facts, as alpine, lacustrine, and marsh productions being related, with the exceptions before specified, to those on the surrounding low lands and dry lands, though these stations are so different, the very close relation of the distinct species which inhabit the islets of the same archipelago, and especially the striking relation of the inhabitants of each whole archipelago or island to those of the nearest mainland, are, I think, utterly inexplicable on the ordinary view of the independent creation of each species, but are explicable on the view of colonization from the nearest and readiest source, together with the subsequent modification and better adaptation of the colonists to their new homes. Summary of last and present chapters. In these chapters one have endeavored to show, that if we make due allowance for our ignorance of the full effects of all the changes of climate and of the level of the land, which have certainly occurred within the recent period, and of other similar changes which may have occurred within the same period, if we remember how profoundly ignorant we are with respect to the many and curious means of occasional transport, a subject which has hardly ever been properly experimentized on, if we bear in mind how often a species may have ranged continuously over a wide area, and then have become extinct in the intermediate tracts, I think the difficulties in believing that all the individuals of the same species, wherever located, have descended from the same parents, are not insuperable. And we are led to this conclusion, which has been arrived at by many naturalists under the designation of single centers of creation, by some general considerations, more especially from the importance of barriers and from the analogical distribution of subgenera, genera, and families. With respect to the distinct species of the same genus, which on my theory must have spread from one parent source, if we make the same allowances as before for our ignorance, and remember that some forms of life change most slowly, enormous periods of time being thus granted for their migration, I do not think that the difficulties are insuperable, though they often are in this case, and in that of the individuals of the same species, extremely grave. As exemplifying the effects of climatal changes on distribution, I have attempted to show how important has been the influence of the modern glacial period, which I am fully convinced simultaneously affected the whole world, or at least great meridional belts. As showing how diversified are the means of occasional transport, I have discussed at some little length the means of dispersal of fresh water productions. If the difficulties be not insuperable in admitting that in the long course of time the individuals of the same species, and likewise of allied species, have proceeded from some one source, then I think all the grand leading facts of geographical distribution are explicable on the theory of migration, generally of the more dominant forms of life, together with subsequent modification and the multiplication of new forms. We can thus understand the high importance of barriers, whether of land or water, which separate our several zoological and botanical provinces. We can thus understand the localization of subgenera, genera, and families, and how it is that under different latitudes, for instance in South America, the inhabitants of the plains and mountains, of the forests, marshes, and deserts, are in so mysterious a manner linked together by affinity, and are likewise linked to the extinct beings which formerly inhabited the same continent. Bearing in mind that the mutual relations of organism to organism are of the highest importance, we can see why two areas having nearly the same physical conditions should often be inhabited by very different forms of life, for according to the length of time which has elapsed since new inhabitants entered one region, according to the nature of the communication which allowed certain forms and not others to enter, either in greater or lesser numbers, according or not, as those which entered happened to come in more or less direct competition with each other and with the aborigines, and according as the immigrants were capable of varying more or less rapidly, there would ensue in different regions, independently of their physical conditions, infinitely diversified conditions of life. There would be an almost endless amount of organic action and reaction, and we should find, as we do find, some groups of beings greatly, and some only slightly modified, some developed in great force, some existing in scanty numbers, in the different great geographical provinces of the world. On these same principles, we can understand, as I have endeavored to show, why oceanic islands should have few inhabitants, but of these a great number should be endemic or peculiar, and why, in relation to the means of migration, one group of beings, even within the same class, should have all its species endemic, and another group should have all its species common to other quarters of the world. We can see why whole groups of organisms, as batrachians and terrestrial mammals, should be absent from oceanic islands, whilst the most isolated islands possess their own peculiar species of aerial mammals or bats. We can see why there should be some relation between the presence of mammals, in a more or less modified condition, and the depth of the sea between an island and the mainland. We can clearly see why all the inhabitants of an archipelago, though specifically distinct on the several islets, should be closely related to each other, and likewise be related, but less closely, to those of the nearest continent or other source whence immigrants were probably derived. We can see why in two areas, however distant from each other, there should be a correlation, in the presence of identical species, of varieties, of doubtful species, and of distinct but representative species. As the late Edward Forbes often insisted, there is a striking parallelism in the laws of life throughout time and space, the laws governing the succession of forms in past times being nearly the same with those governing at the present time the differences in different areas. We see this in many facts. The endurance of each species and group of species is continuous in time, for the exceptions to the rule are so few, that they may fairly be attributed to our not having as yet discovered in an intermediate deposit the forms which are therein absent, but which occur above and below. So in space, it certainly is the general rule that the area inhabited by a single species, or by a group of species, is continuous, and the exceptions, which are not rare, may, as I have attempted to show, be accounted for by migration at some former period under different conditions or by occasional means of transport, and by the species having become extinct in the intermediate tracts. Both in time and space, species and groups of species have their points of maximum development. Groups of species, belonging either to a certain period of time, or to a certain area, are often characterized by trifling characters in common, as of sculpture or color. In looking to the long succession of ages, as in now looking to distant provinces throughout the world, we find that some organisms differ little, whilst others belonging to a different class, or to a different order, or even only to a different family of the same order, differ greatly. In both time and space the lower members of each class generally change less than the higher, but there are in both cases marked exceptions to the rule. On my theory these several relations throughout time and space are intelligible, for whether we look to the forms of life which have changed during successive ages within the same quarter of the world, or to those which have changed after having migrated into distant quarters, in both cases the forms within each class have been connected by the same bond of ordinary generation, and the more nearly any two forms are related in blood, the nearer they will generally stand to each other in time and space. In both cases the laws of variation have been the same, and modifications have been accumulated by the same power of natural selection.